Welcome to the next episode in this mini video series. Today, in keeping with the theme of Halloween, the day I'm recording this session, we're going to be talking about haunting hallucinations. Perhaps the single biggest impediment to taking your large language models, your generative AI projects to production. My name is Vishwas Lele, and let us get started. So let's talk about what is hallucination in the context of large language models. Of course, the term hallucination originated in the medical literature. Here is a quote from a paper in NIH where it talks about hallucination as a sensory perception in the absence of a corresponding external or somatic stimulus. Of course, there's a debate within the medical community that the AI model's hallucination is an imprecise metaphor. Because AI models are not sentient, the notion of an external stimulus does not make sense. Of course, the AI community says that the data that it was trained on can be thought of metaphorically as an external stimuli. Irrespective of where you are in this debate, I would urge you to use caution when using the term hallucination because it can tend to stigmatize people who suffer from mental illness. Now keep in mind that Merriam-Webster recently extended the definition of the word hallucination to include computing, and that's shown here on the screen, a plausible but false or misleading response generated by an artificial intelligence algorithm. So for the purposes of this video, I'm going to stick to this definition and delve into this further. Let us take a look at some of the implications of hallucinations. Anybody who's used these language models, I'm sure, has run into these examples. I'm going to call out a few examples to motivate the discussion here. First and foremost, a healthcare AI model may incorrectly identify a benign skin lesion as malignant, and obviously the problems caused by that. Then there's this example of fake legal precedents, and you may remember this story from back in June of 2023, where a New York law firm, on behalf of their client, I believe in an aviation injury case, submitted legal precedents which turned out to be fake, resulting in a $5,000 fine. Let's take a look at this study that was conducted, an extensive study where they looked for hallucinations in scientific writing, and they found that out of 178 references that were generated by ChatGPT, 28 did not exist at all, and then 41 were not accurate. And then finally, look at another study here, when machines dream, and they found that 93% of the people who are using these models are very concerned about accuracy and hallucination. So no question, this is a problem that is uppermost in people's minds who are using these models. Let us now look at why do hallucinations occur. So here are a few examples. So first and foremost, repeating data. If the model sees the same information many times during the training, it might get fixated with certain phrases or words, and this might cause the model to imagine things. The other example is messy data. Of course, if it has been trained on bad data or incorrect data, it will tend to hallucinate when it is responding to your questions. Number 3, randomness in answering, and many of you are already familiar with something called temperature, which varies the randomness in the response. And of course, depending on what temperature setting or top K sampling you're using, you might end up with a response which has hallucinations. The next example is the built-in knowledge. So the model tends to sometimes overemphasize the information that it was trained on versus the information that is being contextually passed along to it. The final example that I want to talk about, and this is a bit nuanced. So when the training is happening on the large language models, it is trained on correct answers. So it is trained to predict the next word based on correct answers. But when you're using these models in real world, you're asking it to predict something based on the context that you have provided, the words in the sentence that have come prior to the next word that is being predicted. And this difference in the training setting and the usage setting can lead to hallucination as well. And we'll look at an example of that later on in this video. Let us take a look at a few prompts and responses to look at some of the subtleties associated with hallucinations. So here's the first example. Hey, my friend Emma is really into swimming. I'm thinking of taking her to the beach. And oh, by the way, my cousin Jake is coming to the town, and it's been too long since I have last met. If you look at the response from the language model, it gets it right generally, but it also makes an incorrect assumption about something being common between Emma and Jake. It assumes that they have swimming in common, which was not given as part of the prompt. Let us take a look at a few other examples. Here are some notes from a patient that arrived at a medical facility, and here is a summarization generated by the large language model. As you can see here, there is some loss of information. For example, the duration of symptoms, the family history, lifestyle details, and the mention of work-related stress are all omitted. Let's look at another example. Once again, here's a patient that arrived at a medical facility. Here are the notes that were captured. Let's look at the summarization. In this case, the hallucination is even more severe because not only is there a loss of information, some information is plain inaccurate. For example, the originally recorded blood pressure was 160 by 100, but our report states here that it is 120 by 80. Similar inaccuracy exists related to the body temperature as well. So as you can see in this case, unlike the previous example where there was just loss of information, here the information is plain inaccurate. Let us take a look at another example commonly referred to as hallucination snowballing. Here's the prompt. Was there ever a US senator that represented the state of New Hampshire whose alma mater was University of Pennsylvania? Here's the response. It says yes, very quickly, and it goes on to provide an example of Senator Judd Gregg, who served in the US Senate, and it claims that he went to University of Pennsylvania. It turns out that this answer is incorrect. And empirically speaking, if the language model commits to a response very early, in this case, yes was the first word in the response, chances are that it will get it wrong, and furthermore, the hallucination will snowball, and it is going to make up some evidence to support the response. Now, if you went back and said, hey, did Judd Gregg's alma mater happen to be University of Pennsylvania? And then it gets additional time to think, and it says, I apologize for the incorrect response. Judd Gregg did not attend the University of Pennsylvania. His alma mater was Columbia University. So there is an important lesson for us here as we craft prompts. Are we forcing the model to commit too early in the response? Because if that happens, we may end up with hallucination snowballing effect. Let us now talk about some approaches for detecting and mitigating hallucinations. Here's the first approach. We've already talked about the RAG pattern in this video series. The idea here is that you're providing some context to the language model as it generates a response, and by virtue of that context, the accuracy is greatly improved, as shown here in the diagram that is taken from a paper mentioned at the bottom of this slide. So the green bars represent examples with the RAG pattern. As you can see, they have the highest accuracy. I should also talk about the blue and the orange bars. The blue bars represent models that have only gone through pre-training, and the orange bars represent models that have gone through the pre-training, also have gone through supervised learning, and they have also gone through a reinforcement learning from human feedback. And the green bar, of course, represents all of these plus the RAG pattern. So as you can see, the RAG pattern gives you the most accuracy. The one other thing to take away from this slide is you're still dependent on how you frame your prompts. So if your prompts are misleading or hard, the RAG pattern is going to only partially help you. So the RAG pattern in combination with good prompts is going to give you the best chance of accuracy. Here's another consideration when you're dealing with hallucinations. As you go about building applications that take advantage of large language models, it is important to think from the very beginning a framework that will help you evaluate hallucinations. I'm showing you here a diagram that was taken from a paper mentioned at the bottom of the slide. What I really liked about this paper is they define a framework. They call it hallucination QA. that was designed from ground up to detect hallucinations. And if you look at the various steps in this diagram, the first step is that they write questions explicitly designed to induce hallucinations. And as part of step 2, they generate some answers and even select some adversarial questions. In step 3, they write multiple correct answers and wrong answers for each adversarial question, and then they provide supporting evidence. And in step 4, they check for all of the annotated question and answer pairs, and then they remove the low quality samples, but they keep the high quality samples, and that becomes a framework for continuing to evaluate hallucinations. Here is another approach for addressing hallucination, and this diagram comes from a paper mentioned at the bottom of this slide. And here the idea is that once you have a model generate a response, the first thing you do is you identify the candidates for potential hallucinations, which means you identify concepts from the generated sentence that may possibly be hallucinations. So once you do that, you are now going to go check for correctness of these concepts through something called the validation procedure. And what is the validation procedure? You create a query to test the correctness of the information pertaining to that concept in that sentence. And then once you've done that, you retrieve the knowledge relevant to the validation question. You try to answer the validation question, and you figure out if some of those answers are incorrect. And that follows, you have a repair step where you're taking a potentially hallucinated sentence and you're trying to fix it using a knowledge base or evidence. The technique that was mentioned in the previous slide is also sometimes referred to as the chain of verification. So what I'm going to do in this slide is I'm going to go back to one of the examples where a patient walked up to a medical facility and we got some inaccurate summarization. How can we apply chain of verification to address the problems with that prompt? So once again, here you see the prompt, and I'm taking advantage of the chain of verification. So I'm telling the language model that I'm going to give you text, and I'm also going to give you summarization. Your job is to create validation questions, pose them to text and the summarization text, and then give me a summary of the findings. So if you look at the response here, it went ahead and created these validation questions, and here are the responses side by side. Got the age right. The date of birth was not mentioned. But as you can see, it said that the blood pressure originally reported by 160 by 100, but the summarization captured it as 120 by 80. So this is an example of using chain of verification to ensure that you can reduce hallucinations. The final technique that we want to talk about that can help you reduce hallucination comes from a paper mentioned at the bottom of the screen. And the authors of the paper talk about using multiple instances of language models, or maybe different models, to jointly come up with a response and then reason about a response and arrive at a single common answer. And doing so has shown to improve accuracy. As you can see in the chart here, the bars in the red represent output from a multi-model debate, and the ones in blue represent a single model. So here is another approach that you may want to take advantage of if you are trying to reduce hallucinations in your applications. With this, we come to the end of this video. Let me very quickly summarize the key points that we covered as part of this video. First and foremost, think of a framework that can help you measure hallucinations from the beginning of the project. This framework could be quantitative, some statistical approach, or could be human evaluation. And teams are beginning to use concepts such as red teaming to help with that. Follow prompt engineering best practices, simplify complex prompts into simpler ones, provide a few examples, provide a method for the language model to think about a response. That's what chain of thought means. Think about grounding, improving the accuracy using the RAG pattern, but be aware of the pitfalls of the RAG pattern. If the context is imprecise, you may not get the benefits of the RAG pattern. Think about the size and the model complexity. GPT-4 hallucinates far less than GPT 3.5. And then finally, take advantage of techniques like the chain of verification that we looked at to improve the accuracy of your projects. Thank you for watching, and I will see you in the next video in this mini series.